2014 linear motion question 1A. Two cars P and Q travel with same constant velocity, 15 meters per second, along a straight level road. The front of car P is 24 meters behind the rear of car Q. At a given instant, both cars decelerate with different decelerations. P 4 meters per second squared and Q 5 meters per second squared. So they start with 24 meters. Q is going to slow down. Say it ends up here, and P is going to end up here. So the distance between them after this time is going to be 24, is the starting distance, plus whatever distance Q travels, and then minus whatever distance P travels. So we need to get the distance of Q in terms of P, and the distance for Q in terms of T, and the distance for P in terms of T. So let's look at doing that. So we know we're going to use the formula. Distance S of Q, S of P is equal to UT plus a half AT squared. So my variables for P, it's traveling at 15, so 15T plus a half by my deceleration for P, which is 4. So that's going to be a minus 4, it's decelerating, by T squared. So that's the distance for P. So just simplify that to 15T, and that's going to be minus 2T squared. For Q, we're going to have, again, 15 for U, minus 5 for A. So 15T plus a half times minus 5 times T squared. So the distance for Q is going to be 15T minus 2.5 T squared. So I've left out a T here. If I bring this one over, we're going to take away P, S of Q minus S of P, so minus 15T, so minus S of P, and that's going to be plus 2T squared. So I'm going to get 0.5 T squared. So the distance between them in terms of T is going to be 24. Careful, 24 minus 0.5 T squared, and that's going to be 24 plus S of Q minus S of P. So this is the answer to part 1. Part 2 asks us to find the distance between the cars when they are at rest. Okay, so if they're at rest, we're going to use the formula V is equal to U plus AT. So we need to find the time taken for each one to get to rest. So let's look at Q. It was traveling at 15 and it's going to rest. So U is equal to 15. A was equal to minus 5. Just double check that for Q. Yeah, minus 5 for Q, and the 4 was with P. So we're going to have 0 is equal to 15 minus 5T. So T in this case will be equal to 3. And for P, the variables are 15 again for U and minus 4T. So T is 15 over 4. Which gives me a value of 3.75. So let's look at the distances traveled within this time period. So the distance traveled for Q, again we can use UT plus a half AT squared. So the distance traveled for Q was traveling at 15, and the time for Q was 3 plus a half by the acceleration, which was minus 5 by T squared, which is 3 squared. So that's going to give me 45, and we have 9 5s are 45, divided by 2 is 22.5. So the distance traveled by Q is 22.5 meters. The distance traveled by P, I think it's good to write the equation each time just to line the variables up underneath. So 15 by 3.75 The acceleration was 4, so that's just going to give me minus a half by 4 by 3.75 squared. So can I use my calculator for this one? That's going to give me 28 and 1/8, 28.125. Now we have the formula for how the distance between them. It's this one here, 24 plus s of q minus s of p. 24 plus s of q minus s of p is the distance between them. So 24 plus 22.5 minus 28.125. And that's going to give me 18.375 meters.